Thank you, Malcolm. Good evening, ladies and gentlemen. And thank you for making the effort to turn out here on what has actually turned out to be a not very pleasant evening. I'd like to start with an acknowledgement to Rudolf Glossop. He started the company Soil Mechanics and built it to be a premier operator within the ground investigation industry, not on his own, he had help from others. But I was lucky enough to work there at Soil Mechanics Limited for the first several decades of my professional life. And when I arrived at the company, it was apparent that Rudolf Glossop's legacy was still present in the company and also, more broadly, within the industry. And that is something that benefited me personally, and it sort of set me up for many of the things that I have tried to do with my professional life subsequently. I was also honoured to sit with Mr. Glossop and enjoy his pride at the event where we named the Wokingham office of Soil Mechanics Limited after him as Glossop House. My agenda for this evening, I wanted to talk about the terms quality, standards, and standards. And I set myself a task because we have standards with an uppercase S and a lowercase s, and they mean different things, and I hope I've got them all right. I'm going to talk about the standards involved and the requirements for those standards, and I'm going to concentrate fairly heavily on the state of implementation of those standards into our professional practice within ground investigation. Then, perhaps a bit lighter, I'm going to use some case histories to illustrate the interactions between quality, standards, and standards before closing out. As ground investigators, we aspire to carry out high-quality work. We want to carry out a quality investigation, and we want to accord with the relevant standards, as well as following the required standards. You can see how complicated this could get. And one of the things I want to dwell on is, as an industry, how are we actually doing? How are we actually performing in meeting these aspirational tasks? Are standards and quality the same thing? Similar things? Are they linked? Are they completely separate? And can we actually have quality, and that's what we're aspiring to have quality, can we have that without standards and or without standards? And there's a key question which I will try to address as I go through the talk, as to whether standards help or hinder the investigation process. I will try to demonstrate that we need to embrace the whole ethos of standards and standards in order to achieve what should be our aspiration for quality. That's what we're trying to achieve as professionals, as technical experts, and trying to achieve for the benefit of our clients. So I'll start with some dictionary definitions. I've just done a random trawl through dictionaries, paper and online, and come up with these ranges of definitions. Quality is a distinguishing characteristic, the degree or grade of excellence of something, a characteristic or feature that someone or something has, a level of value or excellence, a state of being free from defects or deficiencies, or the standard of something as measured against other things of a similar kind. Standards are ideas about morally correct and acceptable behavior, something that is very good and is used to make judgments about the quality of other things, a level of quality, achievement, or attainment that is considered acceptable or desirable, a document that provides rules or guidelines to achieve order in a given context, something set up and established by authority as a rule for the measure of quality. We also have a definition of standards from British Standards Institution, from BSI, which I will just read out the highlighted bits. A standard is an agreed way of delivering a service which is used by customers and represents the distilled wisdom of people with expertise in their subject. So, in summary, quality is a standard of measurement, and standard is a measure of quality. They're not quite the same thing, as you all know, but they are closely interlinked, and clearly we need to have both quality to maintain our standards and standards to improve our quality. So these ideas, as I first formulated them, led me to the idea of having a wheel, which I then called a square wheel, hence the title of the talk, of quality standards. So if I create a box in which I fill with quality and standards, and then put into it my wheel, and the quadrants of these wheels, these threads within each quadrant, are the threads of personal quality, professional quality, technical quality, and standards. And I just want to dwell for a moment on these 4 threads. What do these threads actually mean to us as practitioners? Personal thread? Well, we're going to undertake appropriate education. That's who we are, that's where we come from. We're also going to undertake appropriate program of development and training, developing our competencies, not least the 7 competencies for chartership. We're also going to carry on developing those competencies through lifelong learning or continuing professional development, whichever phrase you prefer, and we're going to behave well. Professionally, we're going to submit that education and training to peer review in order to measure our development for chartership, for registration, or whatever. And we are going to meet the requirements to act and practice as professionals. We are going to, throughout our career, be mentored. None of us should ever think that we stop developing. And we're also going to put something back, we're going to mentor others. And also professionally, we are required to follow the appropriate code of ethics, and bearing in mind, of course, that this society has 2 codes of ethics which you have to follow. I'm not going to develop that idea, but there are. Other UK bodies also have codes of ethics which you have to follow, and when you work overseas, there are local codes which you have to follow, unless, of course, the requirements are lower, in which case you have to stay with the UK codes. What do those codes of ethics require us to do? Just picking a few highlights from the society's code of ethics for behaviour. Professionals must be honest about themselves, recognise and acknowledge limitations in knowledge and competence, exercise professional skill and judgment, act honourably and ethically, treat others fairly and honestly, and express opinions without bias, without vested interest, and in accordance with established and appropriate rules of behaviour. Just picking the highlight. So we have to exercise professional skill and judgment to the best of our ability and behave as we are expected to behave. So I think that means that in order to accord with the codes of ethics, we have to behave, we have to work to higher standards, and yes, we do have to follow all relevant standards, uppercase S. Coming back to the 4 threads, the technical thread. We have to keep on learning. We all know that the best geologist has seen the most rocks. Given this is an engineering geology talk, also seen the most soils. We have to hopefully have experienced a maximal range of different geological terrains, of engineering problems, and a range of technical solutions to those problems. We attend lectures and seminars and conferences. Well, you do, you're here this evening. We also have to be aware of and use the publications and guidance of whatever state it is. So this is going to be industry guidance, it's going to be the literature in its broadest sense, so textbooks, journals, papers, and so on. And we're going to have to be, in the standard thread, be aware of and follow what is actually a large range of conceptual standards. So the international standards, which can be both normative and informative. The national standards, which can also be normative and informative, and these are issues I'm going to be developing further, as well as supporting information such as NCCI. So, coming back to my wheel, are we using the threads? The personal thread, are we educated, trained, following CPD and behaving well? The professional thread, are we chartered, registered, or at least heading that way and behaving ethically? Technically, are we continuing to read, train, and learn? And are we following the standards? Can you answer yes to that slide? Well, I hope so. Are you using all those threads? Good. And if so, well done. And I like to think of that as Mr. Glossop looking down as thumbs up. But I don't believe that actually in the ground investigation industry, the situation is that rosy. I think we have a rather more difficult problem. And two quotations have come to me recently. One via the BDA, the UK ground investigation industry at the moment is generally out of date, poorly skilled, demoralised, underpaid, underrespected, and barely fit for purpose. And through a more personal front, through a number of consultants who've been talking to us at Equip, the quality of work in the GI industry is the worst it has ever been. Well, those are rather damning indictments, and part of that is the launch of the BDA AGS survey, which is currently underway. So if that's the situation, I'm afraid Mr. Glossop is no longer smiling. Do you agree with these quotes? If you do agree with these quotes, you must have answered no to the previous slide. So we're actually in a rather difficult position. And I believe from these quotes and my own personal experience that actually the quality of the work being carried out in the ground investigation in its broadest sense is low. And how much of this low quality is actually due to our non-compliance with standards and standards? And that's basically what I'm developing now. So, which are the standards we should be following? We need to follow the design standards, such as Eurocode 7, and these are both normative and informative. I'll come back to those words in a moment. There are also a range of test standards, standards for tests that we actually have to carry out in accordance with those standards. There are then some procedural standards, which are also normative, such as 22475 Part 1, which I'll come back to, and also standards such as 14688 and 14689. That's about as far as I'm going on soil and rock description tonight, ladies and gentlemen. You'll be pleased to hear. Then there are the British Standard Codes of Practice, which are all informative, such as 5930 on ground investigation, 8574 on data management. There are also the other BSs, which are generally non-NCCI. And I could try and give you the explanation of NCCI without falling over myself. Non-conflicting complementary information. Whew, managed it. 6031, well, that's actually a British standard at the moment, but there is a Eurocode on earthworks in preparation, so when that comes out, 6031 will slip down to NCCI level. 8002, 8004 have been recently revised specifically to sit in the context of NCCI, and 8081 at the bottom of the slide, ground anchors, that is currently under revision to fit with the work being done under Eurocode 7 and related test standards. I said I come back to the words normative and informative. The design and test standards have a range of being normative or informative. The normative standards, the operative verb in the clauses is shall. You have to do it. You have no choice. The procedural and NCCI standards, and in fact even the contents of several other standards, are informative. And there the operative verb is should. You don't have to do it. Now I'm actually not quite sure how much difference there is between shall and should. In the English language, there's quite a lot. Yes, I quite agree. But in terms of how we actually operate these standards, it's a little more confused, and I suspect it won't be clarified until we have the dreaded situation of case law arriving. Hopefully that'll take a very long time. But regardless of whether it is a normative or an informative standard or clause, you are expected and required to follow what it says, because these standards, whatever they are the British standards of current best practice. That is what you have to do. And the only ray of light, if you like, is that when you are looking at an informative clause, a should clause, you don't have to follow it, but by golly, you better document how you deviate from it. So, Eurocode 7. As I'm sure most of you are aware, Part 1 was published in 2004, and the National Annex in 2007, Part 2 in 2007, the Annex in 2010. And these were all implemented into UK practice in 2010, 6.5 years ago now. We should all be using these with our eyes closed. And other national standards were either withdrawn or revised as appropriate. You'll notice that Part 1 was actually amended in 2013. The chapter on anchors was completely rewritten. Surprisingly, how few people know that, which is worrying. Within Eurocode 7, or arising from Eurocode 7, are some thoughts. Eurocode 7 requires more systematic thought about the degree of uncertainty in the values of geotechnical material parameters for use in design calculations. And it also includes a greater emphasis on the assessment of deformation, which is likely to lead to a greater need for SI providers to consider ground deformation parameters. So that's upping the ante in the data we're trying to provide. Eurocode 7 also has implications. Numerical modelling is increasingly used for design. For the benefits of numerical modelling to be realised, it's necessary to obtain reliable data on the ground's stress-strain properties and strength. And despite advances in ground characterisation, knowledge gaps will be inevitable. Fragmented procurement processes can lead to inadequate investigation. And to show how really, really up-to-date I am, these quotations come from a synopsis from a talk that Tony O'Brien has not yet given. I hope I got it about right, Tony. But the key point about these quotations is actually what Eurocode 7 is trying to do is to get us to have a much better understanding of the key parameters, which are the strength, the stiffness, and the stress-strain properties. In other words, the Eurocode is actually requiring us to do better in our investigations, not worse. What does Eurocode 7 comprise? Well, there are the 10 Eurocodes. Let's not worry about those. But Eurocode 7 has two parts. And there are also the two national annexes. And you can't operate the Eurocode documents without also having open in front of you national annexes, which are the documents that tell you how to actually implement those Eurocode 7 documents into national practice. There are also the 13 execution standards called up under Part 1. And the symbology on this slide is if it's underlined, it exists, it's been published in the UK, and it is the British standard on that subject. If it's got an asterisk against it, it has been changed since the original publication. And as if there are not enough standards, yes, they do keep on changing, and so it requires you to make some effort to keep up to date. So, as I commented, Eurocode 7 Part 1 was amended in 2013, and it says so. But make sure you are using the up-to-date version, make sure that you know what version it is, and it is your responsibility to do so. That, not only do you have to worry about the new standards, you have to worry about them changing. Coming back to the test standards, and these are the ones called up in Eurocode 7 Part 2 and ground investigation and testing. On sampling and measurement, there are 3 standards. On field testing, there are going to be 14. They aren't all out yet, but some of them have already been changed. Structure testing, there are going to be 9. I don't know why the sequences are incomplete, don't worry about that. Permeability testing, there are 6. They came out in 2012 and are the British standards for field permeability testing. Geotechnical laboratory testing, there are going to be 12. The first 3 are out. The other 9 are heading towards you at the speed of light, in standards speak. Instrumentation, there are going to be 10. The first one's out. The next 3 are imminent. And 14688, soil and rock description, there are 3. So there you are. Eurocode 7 is actually 74 documents. That is a lot of stuff to get hold of and to read. And if you are doing a ground investigation, that's the cost, that's the bill. So you've got to be aware of these standards and you've got to buy them, you've got to get hold of them. The first thing is actually be aware they even exist. You can't go and buy something you don't know about. So you've got to go on the internet and you can go to the BSI shop, the BSI website or whatever. If you want a quicker way forward, you can look at my website. I try and keep them up to date there. And there are no pop-ups earning me money. And then, of course, you've got to get hold of these standards. To buy the 43 that are currently published costs just over £6,500. By the time all 74 are published, it's going to be well in excess of £10,000. Just as an aside, it's nothing to do with the lecture, and it certainly won't be in the written paper. Why do we have to spend so much money buying these things, which we have written? Moving on. Although we do not need all of these standards, most companies will actually need to get most of them. So most companies are doing field work, field testing, laboratory testing, description, and so on. So you're going to need to get them. And that bill, that £7,000 or £10,000, that's just to buy them. So now you've spent your money, you lined your copies up on the bookshelf, what next? You've now actually got to do something with them. You've got to read it, you've got to open them, you've got to read them, you've got to understand them. And then you've got to tell your colleagues what they say. You've got to train your other staff. You've got to notify the clients that you're changing. You've got to update your specification clauses, your recording and reporting templates. You may even need to adjust how you can use the results of the testing because you may get different answers. And then you can deploy the procedures into new contracts. So you're actually going to be using parallel procedures, old and new, and that is just a recipe for disaster. But that's how it's going to be. Okay, so that's it. You've spent your £7,000, your £10,000, and you've spent at least as much again actually understanding what they say. Is this the Eurocode scream? Yeah, it probably is. So we don't like it, do we? It's interference from Europe. It's new things. We've got to change. All the things that we don't normally as practitioners like. I will just get in a plug here that this slide hasn't changed from June. In terms of European standards, we are, as UK PLC, have chosen to be a member of CEN, the European Centre of Normalisation. And that is in Geneva. It is not in Brussels. It's nothing to do with the European Commission. So, nothing's about to change. So everything I'm talking about here in terms of the European standards is going to carry on for the foreseeable future. Well, how far can we foresee? So, is it a Eurocode scream? Well, we've got to carry on doing it. And I believe that actually, and what I'm trying to demonstrate to you this evening, is actually if we do follow these standards, implement them, and take account of them in our day-to-day practice, it is a chance for us to actually raise the standards. I've said what I think about where the standards might be. I think it's a chance to raise the standards. So, what are the requirements of these standards? US Code 7 Part 2 has a clause saying that the aims of investigation are to establish the soil, rock and groundwater conditions, determine properties of that soil and rock, and gather knowledge about the site. Well, that's easy enough, isn't it? I trust all of you have no problems whatever with that. If any of you do have a problem with that, I actually don't know why you're here. I won't invite you to leave, don't worry. There's another clause in this one's in Part 1. Geotechnical investigations shall, it's my bolding, shall provide sufficient data concerning the groundwater conditions at and around the site for proper description of the ground properties and reliable assessment of the values to be used in design. Well, that's a pretty tough clause. Shall, you have to do it, you have no choice. And by definition, if you're being challenged about your design, then you probably haven't achieved this. And it's all a matter of how you can prove that what you did was actually as good as you could do in order to achieve the requirements of this clause in terms of data, description, and assessment of design values. And in order to have any chance of having a defense about it, you're going to have to prove that you did indeed follow the standards, in which case you will have had to document your design and your planning, investigation planning processes. So there is actually a requirement arising from Eurocode 7 for much more rigorous documentation of your thought processes. And as geotechnical people and engineering geologists, we're usually rubbish at writing down why we did something. We just say, well, we know we did it. You've now got to write it down. I'm sorry, but you do. So you're going to have to rework to the highest standards and record what you have done and why. That is, to my mind, that is the implication of that particular clause. The standard also assumes that data is collected, recorded, and interpreted by appropriately qualified persons. Execution is carried out according to the relevant standards and specifications by personnel with appropriate skill and experience. And the structures are designed by appropriately qualified and experienced persons. Okay, I'm sure that in your practices, the designers are indeed qualified and experienced. No problem at all. And that the people carrying out the work are indeed appropriately skilled and experienced. But just dwell on the first bullet here. We're back to data is collected and recorded by. So this is down to the level of somebody going out to do a test, take a measurement, collect some samples. That is data collection. And so that person has to be appropriately qualified for the task they're going to do. Okay, no problem with that. And I'm sure you would have no problem with achieving that. Today, so you're going to send somebody out on site today or tomorrow or whatever it is to do a test. Do you know how to do the test? Yes, okay, off you go. No, okay, I'll brief you. That's no problem. You've done it, you've sorted it, you've made sure they're appropriately qualified. But how are you going to prove it retrospectively? When your job goes belly up, that's 5 or 8 years' time. How are you going to prove that the day you sent that person out to do that test or that bit of design work or whatever it was, they were indeed appropriately skilled and experienced? Where are your transparent and checkable HR records that will allow you to check back to skill levels at that time? That's a tricky one. Just dwell for a moment on a small number of stats. I'm not going to go through the whole lot, don't worry, that's several days' lecture. But just dwelling on a 22475, for instance. This is methods of sampling and measurement. So part 1 talks about fieldwork methods, sample quality, and measurement accuracy. So, just on sample quality. We want a class 1 sample because we're going to use that sample to measure strength or stiffness. That's what 2247 requires. You want a class 1 sample if you're going to measure strength and stiffness, so that's what we're going to do. So we can specify what category of sampler we want to see used in the field. We don't want that rubbish stuff, we want this nice stuff. Good. We can also specify what class of sample we want to see come through the process to go into the laboratory testing machine. Yep, we can do all of that. We can write that up before we even go out to site. No problem at all. But we cannot specify what class of sample is actually achieved. Soil can have coarse particles in it, which can damage the sampling. How did we did you actually specify how you wanted the sampler intruded into the ground? Is it pushed or is it driven? Driven samples are never going to be the same quality as pushed samples. And was the driller having a good day? Yes, they do have bad days. Okay, you can't control that. So at the end of the day, who actually decides that the sample that you've taken out of the core liner, the tube, whatever, is actually class 1 and suitable for your strength or deformation test? Is it you? No. Well, extremely rarely, it's you. Is it the geologist or the technician in the field? Pretty rarely. Sometimes, yes, but pretty rarely. Most commonly, it's actually the laboratory technician. Now, I have nothing against laboratory technicians, but what does the laboratory technician actually know about your project and your design requirements? Nothing. His job is to get the sample extruded into the machine, machine's then earning money. Lab's doing its job. Fantastic. So I have no problem with that. That's absolutely right. But you have no idea what sample quality of sample has actually arrived in the testing machine. So we have a major, to my mind, we have a major disconnect. When I started at Soil Mechanics, I used to, if I was in the office, a couple of hours every morning inspecting the samples that were going to go into the machines and commenting on whether they were suitable or not, and if they were unsuitable, stopping them going into the machines. That was routine. Doesn't happen now. So we can specify the quality and the samples that we want. We don't check what's actually being used. So we may actually be apparently or superficially following the standard, but without achieving the quality or standard, lowercase s, that we intended or hoped for. So we need to connect together better. So there's more to the standards than just following the black and white. Moving on briefly to 22475 parts 2 and 3. Now these ones were published in 2011 and are notable by the fact that they are not NISOs. These are not European standards. These are pure and simple British standards. We think that the European standards were up to the mark, so we took them further. So these two standards are normative, shall standards for the people and companies that carry out investigation work. Part 2, on personnel. The lead driller has to have a list of competencies which are documented, which basically means that the lead driller has to have the NVQ in land drilling. And his audits need to be up to date, and there needs to be a lead driller at each rig. Okay. The responsible expert signing off the field report shall be chartered and registered. Quite a tall order. There are only just over 400 registered engineers, roadjet people in this country. How many checks are being made along the supply chain that actually the lead driller at each rig has his NVQ and it's up to date, and the responsible expert is registered? The question is rhetorical. But this is a normative British standard, and you are therefore required to follow it. Part 3 talks about third-party audit. The company carrying out the fieldwork shall have the appropriate equipment, well maintained, sharp cutting shoes and so on, calibrated where appropriate personnel, as in the previous slide, and that should be audited every year by a third party for compliance. So every company carrying out ground investigation should have a 22475 Part 3 certificate that is less than 12 months old. That's what the normative British standard says. Have any of you ever checked or seen a 224753 certificate? I thought not. Right, but that again is a normative British standard for geotechnical investigations. Moving on to field testing. 224762, 2 dynamic probing, and 3 SPTs. Hammer calibration is now mandatory, with the energy ratio to be reported. Well, we implemented that in 2007. It took a few years, but we got there. And I think it's probably true to say that all the hammers in this country are now calibrated and are being calibrated every year. Good. We've moved forward. But actually, as a result of that moving forward, we found something else. We found that actually, if we stabilize the drill string, the quality of, or the repeatability of the energy per blow in the calibration improves greatly. But the standard is silent on this. So actually, we have a chance here. We've had a European standard come in, told us we've got to calibrate our hammers. Out of that, we've realized that we need to stabilize the drill string. So we can actually go back to the loop now, revise the standard, and up the ante even more. That's great. Fantastic. Also in 22476, 2 and 3, there's a rod straightness requirement. The rods shall be straighter than 1 in 1200. That's a mandatory requirement. It's nothing new. It was in 1377 Part 9 way back. What is new is you have to check that straightness every 20 tests. That's at least once a week for most SPT hammers. Yeah? Have you ever done it? That's right, you don't have to answer. Because I have been asking this question in my audiences over the last several years, and I've recently found one person that had actually checked a rod straightness once. These standards have been in place since 2007. So is the rod straightness ever being checked? I've had drillers say, yeah, I do it. Yeah, did you record it? Oh, no. In that case, you're not doing it. And I have not yet seen a driller record sheet, template, with a box to record that the straightness check is carried out. Now, whether you think a straightness check is good, improves standard, whatever, I actually don't care. The standard says you shall do it. Have you done it? No. Even worse, your operating to a specification says that you shall do it because you shall do the test in accordance with these standards. And you're not reporting that you did do it. No, you didn't. And I reckon we're carrying out something in the order of, it doesn't matter what the number is, but several thousand SPTs every year in this country. And none of these are being carried out in accordance with the standards. None. If any of you like to try and convince me afterwards over a glass of wine that they are, I'd be delighted to hear from you. So, does this non-adherence to the standard matter? Yes, it matters greatly for 3 reasons, or 2 reasons. One is that you then write a report, or receive a report, that the test's been carried out in accordance with the standard. No. Also, we carry out quite a lot of geotechnical design based on the SPT end values. Well, let's park whether you think that's a good idea or not. It may or may not be, it doesn't matter. But surely, if the standard says you shall check the straightness of the rod, therefore you shall improve the quality of the test result, shouldn't we aspire to that? Yes, of course we should. So we want the results to be as good as possible, and that's what the standard is trying to push us to, and we don't like it, so we're not doing it. That is not acceptable. So, I've just highlighted 4 standards by way of illustration that we are not implementing all of the standards, and I saw in rock description does come up again. I slip it in at the bottom there. Those are standards we are following. So we're following some, we're not following all. So where are we with the current state of implementation, and why are we doing it? Well, we go back to where it all came from, that the implementation of the Eurocodes is basically linked to the Construction Products Directive and the Public Procurement Directive. And what's going to happen to those particular directives following Brexit is anybody's guess, but I suspect they're not going to go away. They're just going to transfer into British law. So they're still going to be relevant. So Eurocode implementation is actually by statute. So public works are required by law to follow the Eurocodes. Private clients do not have to. They can choose whatever standard they want. And in terms of the drivers for implementation of the standards, the suppliers, to my experience, the suppliers have been the lead, the funders have followed, the clients are lagging behind, and us, the geotechnical industry, well, we might try and persuade our clients, we might or might not achieve something. Okay. But actually, implementation of these standards, and I mean all 74 standards, not just Eurocode 7 itself, implementation of these standards is necessary. We cannot carry on with our heads buried in the sand using out-of-date practices. We cannot do that. It's not acceptable. So why aren't we implementing? Why don't we like it? Why are we sitting on our hands? Are we suffering from indigestion, reluctant to change, too conservative, fearful of stifling innovation, afraid of the cost? Oh dear. Let's just explore these thoughts a little further. Indigestion. Yep, there are 74 standards. It's a lot of eating to do. And I accept it's a good point, but actually, I'm sorry, you have no choice. These are the British standards for these activities. If you're doing that test, that procedure, that design, in accordance with the Eurocode, and you're saying that you're doing it in accordance with the Eurocode, you have to follow it. Are you ignorant of the standards? Are you ignorant of their existence? I hope not, otherwise you really do have a problem. But are you ignorant of the awareness, ignorant of the contents, at least in full? None of you are checking rod straightness. Ignorance is no excuse for anything, but is perhaps a symptom of low standards. Are we too lazy? Well, that one doesn't actually merit much time on for me. Are we reluctant to change? I've always done it this way, so I'm not going to change. It's fine. But the old ways are often not the best ways, so I come back to N values. We commonly determine soil stiffness or strength from N times a factor, because we've always done that. But come on, there are much better ways of determining stiffness than using an SPT N value. Or are we reluctant to change? Yes, we are a conservative profession. We try and design things that don't fall down. So we err on the side of caution in our approaches. And therefore we have a feeling that actually what we've always done is safe and reasonable, not necessarily supported by any evidence. And in today's world, actually conservatism is an unrealistic luxury. A common bleat. Eurocodes stifle innovation. I'm not convinced by this one. Are the Eurocodes any worse than other previous standards? Yeah, I know they've got shall clauses in them rather than codes of practice, but actually there's a lot of room for manoeuvre. So in the Eurocodes, we have the principles, which are the shall clauses, and the rules, which are the should clauses. They're both there, and most of them are actually rules clauses. The principle clauses are comparatively small in number. And the idea of the Ps and the ARs was to enable and stimulate innovation. Eurocode 7 Part 2 contains lots of guidance on the direct use of the results of field and laboratory tests in geotechnical calculation. The UK National Annex specifically allows these not be used, and encourages use of the most appropriate derived parameters and calculation methods. So there we are in our national annex, we're telling you, yeah, it's jolly interesting, but you don't have to do it. And in fact, the Eurocodes, I believe, are less prescriptive than the British standards, with more aspects left open to the designer's judgment and comparable experience. What do I mean by that? Well, your EC7 says it's documented or other clearly established information related to the ground involving the same types of soil and rock and for which similar behaviour is expected. Information gained locally is particularly relevant. And I've done a count, you've got to be slightly constructive in the count, but about 40 mentions. That's about every 2 pages. There's a mention of comparable experience. There's room for manoeuvre within Eurocode 7 Part 1. So I don't think stifling innovation stands. So there's my list of 5 on the left. If 1, 2, or 3 are applying to our practice, then we're probably being incompetent and or unprofessional and or unethical and quite possibly negligent. Innovation? Don't agree. Cost? Yes, that's a good one. Let's explore cost a bit further. Is it the implementation cost? We don't want to hear about these new standards. It's too difficult to keep up with them. They cost too much time, cost too much and too much time to acquire and implement them. Well, if that's your attitude, I'd quite like to be on the other side when you appear in court to maintain your design. But more realistically, I think it's probably actually the cost of the investigation and fear of what the client will say about how much the ground investigation will cost because we're following Eurocodes. I've been carrying out Eurocode 7 workshops over a number of years, and so in a completely non-scientific survey, I asked my delegates to design a ground investigation at the beginning of the day, and then asked them to redesign it after I've lectured them on Eurocode 7 Part 2, and compared the cost increase. And the range is 85 to 150%. Yeah, some people even thought it got cheaper. It's interesting. Anyway, don't worry about that. But anyway, the typical range was the costs increased by 20 to 30%. That's pretty piddling money, quite honestly. I cited a quotation earlier on about standards being at an all-time low. Those respondents actually went on to say in the next breath that they would also be more than happy to pay a premium of 20% provided they could see an improvement in quality. The concurrence of the 20% figure on these 2 slides is purely coincidental. But there we are, we're saying that actually, if we think that Eurocode 7 is going to push the price up by 20%, and the consultants are saying that's a price worth paying, what's the problem? But let's think about this 20% a bit further. Tim Chapman figures for the cost of a building investigation, published in 2012. If we have a building in a city for which the ground investigation is, say, 40k, doesn't matter, it's Tim's figures. And that amounts to 1.7% of the substructure cost, not the whole building cost, but just the substructure, the bit below ground. By the time you get to the whole building, we're down to 0.1%. Negligible for the whole building costs. If we now increase the cost of that investigation by 20%, that 1.7% figure rises to 2%. Still piddling. Yet we're going to get a much better result. So the aim of our investigation is to reduce the risks. And the risks in this context include inadequate performance, overruns in time, and overruns in cost. That's actually what matters to the client, not just how clever we have or haven't been. So adequate and appropriate investigations need to be carried out to undertaken to identify the ground hazards and allow safe engineering. So we need to carry out the right investigation. Eurocode 7 has explicit requirements. You have to do the desk study. You have to do a site walkover. And once these are done, you can plan and execute phased investigation with review and update loops. And then continue investigation through and beyond the construction. There's also suggestions within Eurocode 7 about the intensity of investigation. Spacings and depths. I'm not going to go through the numbers, it doesn't matter. But on depth, that the investigation shall go to at least 5 or 6 meters below the deepest part of the foundation. Piling contractors would love it if they didn't have to guess the ground conditions. We're not following these standards. Now, these spacing and depth are suggestions. They're informative suggestions. But the UK National Annex says on this matter that these recommendations should be treated as a minimum, only relaxing where there is sufficient previous knowledge, and that you should state that in the GIR, in the report. Are you doing that? Are you considering that these spacings, these depths here, are the minimum requirement from which you're building your investigation intensity? That's what the standard requires you to do. That's what the National Annex tells you to do, and that is part of the standard. Too many investigations are planned by non-specialists. I'm still horrified at the number of investigations I see where a contractor has received a request to do 4 boreholes, 3 pits, 2 tests, whatever it is. And that scope has come from the client. What does the client know about geotechnical or ground investigation? Probably not very much. So in many, many investigations, the wrong questions are being asked of the investigation. And if the wrong questions are asked, there's almost no chance of getting the answers to what would have been the right questions. So it is very important that we include expertise from appropriate skilled advisors in planning and execution of GIs. And to this extent, in the revision of 5930, we spent a lot of time talking about geotechnical advisors, and I refer you to clause 6 thereof. Inadequate investigations. These are fairly old statistics now, but they still shock, and I'm not sure things have improved since then. These were collected. 50% of industrial building projects overrun by months, 37% due to the ground. 33% of commercial buildings, half due to ground problems. Highway projects overrun by 135%, half due to ground conditions. Those statistics are a really severe indictment of our industry and the standards and the relevance of what we're doing. These ground problems, in these cases, can be traced back to inappropriate and/or inadequate investigation. What is an inadequate investigation? It's the encountering of unforeseen but foreseeable conditions. So stronger rocks, weaker materials, more fractured materials, less fractured materials, differences in the weathering, both degree and extent, groundwater. That's the most common one of all, and cavities. And I'll share with you a quotation from somebody related to the Casselton Dam forensic investigation, which I'll be talking about shortly. And as that forensic investigation started, a statement was made in the local press to say that the forensic investigation was looking for something. It's difficult to say what it will be until we find it. When we come across it, we'll know what it is. But if we know what we're looking for, we wouldn't be looking for it. I've had that quotation in front of me since 1984, and I still don't understand it. So what is an adequate investigation? Well, I've just demonstrated the expenditure on investigations is low, 1 or 2%. And adequacy is even within that budget, is reducing the uncertainties to an acceptably low level. And here I showed another quotation with you, rather more ordered and understandable from Mr. Glossop himself in his Rankin lecture. If you do not know what you're looking for in an investigation, you're not likely to find much of value. And with that one, I completely understand what he's saying, and I completely agree with him. So, why aren't we implementing? Perhaps the problem is not so much the cost of the investigation. As I say, the amounts of money involved are fairly small, but actually down to a lack of poor communication about the benefits of that investigation. We complain about being the poor, continually we're complaining about being the poor relation of the supply chain. But do we talk to the right people in the right language? I take a quotation from Jim Griffith's Glossop lecture. A critical requirement for an engineering geologist is the ability to communicate their findings effectively by whatever means, and knowledge of the ground is useless without the ability to communicate it. Quite agree, Jim, absolutely spot on. But actually, I'm talking about investigation planning when we're trying to sell our investigation services to our client for an adequate investigation. At that stage, we have very little knowledge about the ground. We don't actually have much to present to the client, in Jim's terms, and so it's even more critical that we actually really understand what we do know, what we don't know, and what we need to know. Our clients are usually lay people, geotechnically and geologically speaking, and they don't understand the value of the work. And if we talk to them in terms of the ground conditions, the water conditions, we've probably lost them already. We need to be talk about them. What are the costs? What are the benefits that our investigation is give them? So we mustn't talk too technically. And we need to head it towards a discussion about risk mitigation in the terms that the clients will understand. There was an ad hoc survey at the Geotechnical Conference earlier this year, led by Andrew Milne, where he handed out duck quackers to all the delegates, and the volume was the answer to the question, the volume of duck quacks. And delegates agreed that the services offered across the industry can be high caliber, lots of quacking, but that we're poor at promoting ourselves, yep, and poor at making ourselves heard and hesitant to change. And in particular, the people to blame for this situation are ourselves. We need to stand up and take action rather than just repeating words and mantras, i.e. whinging and complaining. So this is 16. This was earlier this year that a room full of about 100 geotechnical people agreed that we're poor at communication, but we can do good work. I think that's a very accurate representation of what I see in the industry. So we must put the risks into a context that clients understand, and bear in mind that geotechnical engineers are just one of many technical disciplines vying for the client's attention. We need to emphasize and demonstrate that cheapest is not the lowest risk, not safest, and early investment will reap benefits in saving time. And we all agree that. So, we have a lot of standards. It's a pain and expensive to get hold of them, to read them, and to implement them. So it's a lot easier than start. It'll go away, won't it? We don't need to bother about that. We can just carry on. But why do we need to implement? Well, as I've said it before, we actually have no choice. These are the BSs for ground investigation. And also bear in mind, going back to the BSI definition of the standards, they're the encapsulation of current best practice written by experts, and you are required to follow them. And Steve Denton, the UK chair of CEN-TC 250, the top committee for Eurocodes, international standards play a key role in providing an underpinning framework for international trade. Those countries instrumental in the development of the standards benefit when other countries choose to adopt them, as is happening with the Eurocodes. These standards are not only being implemented in UK and Europe, they're being implemented in a number of other countries around the world. So if we're involved in using them, developing them, using them in this country, we're in prime position to export as well. Just a few questions about the standards before I go off this topic. Do standards, uppercase S, improve quality? Well, no, not of themselves. Blind adherence does not produce quality, as I illustrated by sampling quality in 22475 Part 1. Standards do, however, provide a baseline performance. In particular, standards improve communication. And Scott was referring to these sort of benefits in his talk earlier on. The standards are written to give scope for judgment, and I believe that if used properly, this gives plenty of scope for quality. So standards, properly used, should encourage efficient design and innovation, increase reliability, and reduce uncertainty, which after all is what we're trying to achieve. Do the standards incorporate relevant experience? Very much so. They're written by experts who know what the business is all about. Do they allow and encourage efficient design? Yes, because of the explicit requirement for careful thought in parameter characterization and the use of various design situations in the calculation. I don't believe they stifle innovation. And I hope that in this talk so far, I have convinced you of the imperative to adopt the various and numerous British standards in order that we can stand any chance of meeting our quality and standard obligations. So, I'd like to turn to illustrate some of these points with some case histories, considering what happens when standards are not followed, standards slip, or quality falls. And the examples illustrate shortcomings giving different outcomes in terms of the effect on quality standards and standards. And these case histories are from my personal experience where standards have slipped. And I'm using them here primarily to actually capture the information contained in these histories within the printed version of this lecture. Because what has become apparent to me is that the industry is suffering from a very short memory. We no longer publish case histories or seem interested in doing so or are able to do so. And that means that the lessons we should be learning are forgotten. So I go back a bit and find some of these, what to me are seminal case histories. I'll start with Casselton Aqueduct, which is a 10-kilometre tunnel going from Casselton Water on the left to Ambergate on the River Derwent on the right, and it's just a water transfer tunnel between the river and the reservoir. The reservoir itself also under construction, as you'll see in a moment. And this particular tunnel was to be driven from 4 adits with road headers actually specified for the rock excavation. Interesting approach to the contract. And 3 of the 4 road headers were soon abandoned as the rock was too strong. And by soon, I mean within a few weeks. We had to retain shields in 3 of the drives in order to build the segmental rings. Yes, I know this was self-supporting rock, but the rings had already been ordered and, in fact, were already filling up several fields of Derbyshire. So we maintained the shields, we got rid of the road headers, and we used, basically, even with the shields present, we're using drill and blast. The geology was partly understood. It was fascinating. It was glorious. Sorry about the engineers. This geology was absolutely amazing. We went right through a delta, right from the back of the delta, so the shallow water sandstones, right through to the deep water mudstones, and everything in between in 10 kilometres. Wow, fantastic. So we had sandstones, varying, but particularly ranging up to very strong gritstones. We had mudstones, which were both medium-strong mudstones with open joints. Yep, the joints open up to about 30 mil. And also were very weak and squeezing. Big range. The faulting patterns and their effects on the groundwater were poorly understood. And if you're down 100, 200 metres below the ground and you've got 200 metres head of water as a miner, you'd quite like to know what's on the other side of the fault, wouldn't you? And that's actually what we spent a lot of effort trying to sort out so that we didn't have nasty surprises. And the ground was intersected by growth faults. And the diagram there is to illustrate that growth faults look remarkably like slip surfaces, which is exactly what they are, still picked up by tectonic movements subsequently. So the point is that the faults are curved, they're not 60 or 70 degrees, and they go to a basal décollement level. Fascinating stuff. Not new, even at that time. How many of you have ever heard of growth faults? You don't have to answer that. Okay, so for the aqueduct, the desk study was done, an investigation was done. Was it targeted at the right geology? I'm not going to answer the question, but that's just the question I pose. But bear in mind that after the construction started, we had to carry out additional investigation, which was at least as much again as had been carried out in advance. We were having to drill and blast in the sandstones because they're just too strong. We're having huge quantities of grout in the mudstones because of these open joints. And several times we actually almost lost the tunnel because of the squeezing forces on the shields. So pretty wide range of conditions. And in fact, completely unexpectedly, we also hit that basal décollement layer for about 1 kilometre in the tunnel. It was like a hall of mirrors. It was glorious. All these polished surfaces with 200 metres head of water on it. Fastest production on the job. 1 stick, 3 metres pulled. Fantastic. Anyway, the tunnel was eventually completed several years late, and the cost was never revealed, hidden away in contractual claims. So, the standards at the time were followed. The execution of the GI was satisfactory. The scope was insufficient. The geological context was misunderstood. The ground model was poor. Erroneous conclusions were drawn. And a previous experience in this geology After all, there have been lots of tunnels driven in Derbyshire. Experience in this area was poorly remembered. Not very good, was it? So if we now go to Casselton Dam, which is a project that more of you will have heard of, I'm sure, and I use this picture purposely to indicate public exposure of your failures. I'm standing on the verge of the A road passing the site. So anybody driving that road could see that the dam didn't look quite right. But I'll leave it to Tony Waltham's rather clearer photograph to show you what had happened to the dam when it was nearly completed. So, as far as I'm concerned, this all started off with a tension crack forming in 1984. I'll come back to the history in a moment. And this is just another illustration that tension cracks like this, failures like this, always start at weekends. I don't know whose law that is, but it's a real one. So, this tension crack started at the weekend, quickly got a bit bigger, and got bigger. So this is the backscot. That's that tension crack 10 days later. So there's the failed dam crest, now looking down onto it. So we had a 15-metre vertical drop. So we've got some of the dam crest down there that the rigs are on, some of it up at the right. And the toe of the dam had moved out 5 or heading for 10 metres laterally. That's a failure. This actually wasn't new. The actual movements started at least one earthworks season earlier, where the contractor initiated a remedial profiling, toe loading of the dam to try and stop the movements, but that all became history with the 1984 collapse. So we were commissioned to start a forensic investigation of the collapse, mapping the deformations within the bank, investigating the ground beneath the bank, and recording the ground conditions out with the bank. So, logging the internal structure, geologist heaven. Look at all those things you've got to map and record. Fantastic. Fill, limestone, natural ground, whatever. We also carried out trenches through the base of the dam to look at the area where the slips had taken place, through the base of the fill and through into the top of the natural ground underneath. We're finding shear surfaces, not particularly difficult when they're that clear and striated. We carried out real boreholes. Okay, that's a 250 millimeter diameter piston sampler. Have any of you ever used that? Fantastic. But it gives you a high quality sample. And there you are, you can map the shear surfaces higher up within the dam failed bank profile. We also carried out trenches out in the natural ground. Here we see a young Tim Spink looking for shear surfaces. That's right, I was young then as well. And mapping the shear surfaces in exposures. Yep, that shape's familiar to several of us, all of us, whatever. And recording the presence of glade shear surfaces. Lovely stuff. But there's nothing new in these features. Yeah, they're fantastic, but there's nothing new. They're also present when Walton's wood failure took place back in 1961. This is construction of the M6. And there you are, some thin sections through the shear surfaces, very clear to see, and when you look under the microscope, you can actually see the realignment of the clay minerals. So nothing new. In fact, the nothing new went back even further. If we go back to 1937, the Chingford failure, the reservoirs now known as Sir William Girling reservoirs, where a slip occurred during construction, fortunately also before any water had been stored. And the failure surface was found there to include a periglacially sheared head deposit, yellow clay. This and in fact Skempton and Bishop were called in, Tsagi was called in, and so this failure actually probably was the tangible birth of soil mechanics in this country, both the science and the company. Coming back to Casselton, that is the cross-section of the dam as intended, and you can see nothing particularly untoward about it. There's a rather odd-shaped clay core with a boot, which is specifically to get the grout curtain away from the centre line of the dam, but gives an odd effect, particularly when we realise that the yellow clay, which also existed at Casselton, and that was Skempton's first remark when I met him on site, they've left the yellow clay in again. Yellow clay was left in underneath the bank. So there you can see a very clear preferential slip surface waiting to happen. That's exactly what happened. So the causes of the failure of the Casselton Dam, and these are from a paper by Kennard and Bromhead: limited geotechnical input, too few strength tests, unrealistic surfaces analysed, instrumentation data not utilised, and the dam incorporating an oddly shaped core, maximising the length of potential slip through the comparatively weak element, and the yellow clay was left in place. So, Casselton Dam, training, precedent experience was lost. The ground model was flawed because the yellow clay was not understood and it was left in place. The internal shape of the embankment. Procedural failures, the warnings from progressive failure were ignored. The cost there, again, I don't know what is in pound notes, but basically the whole bank was taken down and rebuilt again. Long delay, big cost to Clout. Coming a bit closer to this lecture theatre, Heathrow, when the Heathrow Express station was under construction in the central terminal area, so between terminals 1, 2 and 3, back up to the mid-90s here. And this tunnel was, these underground works are being excavated and supported with a sprayed concrete lining, here concrete being sprayed, and a sequential excavation to enable construction of the lining to provide to build up to getting the circular profile and its support step by step. And so there it is, the tunnel's under construction, lovely job. It had got to the point of the access shaft, and a couple of the two running tunnels had started. The concourse tunnel had also got underway. Got about that far at the time of the failure. Oh dear, tunnel no longer under construction. Fortunately, the failure happened slow enough that actually all the workers could walk out. So nobody was hurt. Phew. I repeat my comment about public exposure. This time I'm standing in the Terminal 3 car park. And you don't need to be geotechnically minded to realise that something is not quite right. Particularly since actually that weekend you couldn't get into Heathrow because the access roads, and particularly the tunnel into the central terminal area, were full of lorries delivering concrete to try and stabilise the failure. So here we are with the remedial works, and we see the main rescue cofferdam. That's much bigger than the original shaft, under construction there, and the two running tunnels with shafts down to them to enable their construction to recommence. And our brief was to carry out a forensic investigation of that 35-metre cofferdam. So there you are, the geologists logging in a construction environment there, all the different materials, including exposure to the London clay. And I only put this slide up because I have to put it up, because anybody who believes that London clay is not a weak rock should think again. Right. Also, we carried out logging of the tunnels when we got down there, and this, I believe, certainly was a first at the time, and I don't think it's been gainsaid ever since, is the only time that logging of the tunnel has been carried out from the outside in. Okay. But there we were, logging the tunnel, the concrete, and up to 7 different types of concrete being identified. And we worked on this for about 3 months, and we logged about 5 kilometres of trench faces, plus exposures, cross-sections, and so on. Took a few photographs, videos, some things, took a lot of survey, and basically collected about 35,000 records, which included about 400,000 items of data. It's not bad in working 24 hours a day, but that was the task. That's what we did. And all of that data could be rendered into a 3D ground model, and here you see the cofferdam, the original shaft in the middle, and the brown is London clay, the pink is weathered London clay, and the yellow is terrace gravel. There are a few other things as well, but don't worry. And I just sort of keep on dwelling on the thought as, how does that terrace gravel go all the way down there? And I don't know the answer. So, as a result, because of the particular contractual arrangements there, the project was centrally insured, so there were no major contractual claims, but Health and Safety Executive were unhappy, and as a result, they prosecuted the contractor and the consultant. And back there in 1999, the health and safety fines were £1.7 million for failing to provide a safe place of work. So significant penalties there. So the reasons for the failure, well, actually, they were never publicly aired because it never went to court. There's no technical reconciliation of what had been found. The engineering geology is well understood. Well, it's terrace gravel over London clay. It can't be much more complicated than that. But the anomalies weren't investigated. The interaction of the tunnels, less than diameter apart, particularly in the context of their comparatively soft sprayed concrete lining, were forgotten. There was a lot of instrumentation in. It wasn't read. The quality of construction was poor. And in fact, this wasn't a geological failure, it was an engineering and quality assurance failure. Or more particularly, the sprayed concrete lining, the strength of that sprayed concrete was appalling. A lot of it went off for test, and most of the test results came back as null, too weak to prepare specimen. Nobody noticed that. And actually, because of that quality, a lot of the sprayed concrete lining need to be remediated, and by taking it out, they lost the hoop support that by then had been constructed. There's a significant lack of awareness of the critical elements in a sprayed concrete lining construction. The various bits of the reinforcement need to be connected together. Okay, and the observational approach was clearly not followed. And again, the costs weren't published, but from contemporary records at the time, it was well above £200 million. And actually, the delay wasn't too great. The delay was a small number of months, but it required a lot more effort to get there on time. And finally, just an example of tunnelling in the chalk. Sorry, Rory, I did say I wouldn't mention chalk, but I've forgotten it crept in here somehow. Syria 574 chalk classification concentrates on fracture spacing and aperture for very good reason in underground works in terms of the prediction of the groundwater conditions that might obtain within the tunnel. So a drainage tunnel was under construction, and there was a large unexpected increase in water flows and thus costs, and a relogging of the cores resulted in a doubling of the number of fractures recorded from those cores. So here we had a case that was purely and simply a failure of site investigation practice, with the standards not being followed, and in this case, that poor logging resulted in a cost of the order of £15 million. Just from the standards not being followed. So, those 4 case histories. The engineering geology was poorly understood in 3 of them. Training was inappropriate in 3 of them. Precedent experience forgotten was in 3 of them. Standards weren't followed in 3. Construction quality and supervision was poor in a couple, and the quality of work was poor in a couple. And in fact, you could actually take this definition of quality slightly higher and say it's poor in all 4. I'll discuss these issues in a bit more detail in the written paper. So in these cases, the requisite quality and standards were not achieved, and as a result, safety suffered, reputations were damaged, projects were delayed, costs increased, and litigation was possible. And that list I've lifted from Eddie Bromhead's talk to Geotechnica earlier this year. Any one of these outcomes is a high price to pay for not achieving the requisite quality and standards. So there we are. We've got 4 case histories where things have gone wrong, and basically it's a disaster for a variety of reasons, not least just the project itself. So the current position. We all know that you pay for a site investigation whether you have one or not. And most geotechnical engineers think that clients worry more about the budget, the cost of their investigation, than the time or the implications of unexpected ground conditions. The cheaper the site investigation, the more risk there is. That's obvious, and we have to achieve a balance between the cost of the investigation and identifying the risks. And as I've illustrated, we need to improve our communication skills and the relevance of our message to our clients. So coming back to the wheel. We need all the threads in place. The education and training and chartership and ethics and using the technical guidance and following the standards. All 4 of those threads need to be in place if we are going to fulfill our quality, standards, and standards obligations. And that means taking on board the requirements and ethos of all the standards, uppercase, and standards, lowercase, not just the ones we like, so that we can meet our professional standards, satisfy our ethical codes, protect our professional indemnity, and improve our standing in the eyes of our clients. And hopefully, once we've achieved that and negated the quotation I gave you earlier, we can also hopefully improve our own view of ourselves. So coming back to the screen, is this all change and so something nasty? No, I think it is. This is the opportunity for the GI industry to raise the quality bar. We've been whinging about this for decades. This is our chance, our one big chance to raise the quality bar. We even have something to blame for it. We can blame all these normative standards that are new from Europe. And that's why we're having to change. And I believe that if we embrace these and do so wholeheartedly, we will raise our standing in the eyes of the clients. And perhaps then the AGS BDA can stop inspecting our mutual navel because we'll have raised the standards and our quality. So it is not the Euro scheme, I believe. If we follow and use the standards, we should be able to achieve high quality. So I implore you all, and all your colleagues, to go out there, read the standards, understand them, implement them, to aim high in our standards, lowercase s, and therefore achieve high quality. And in order to do so, we do actually need to believe in ourselves. So that's your mission, ladies and gentlemen, and good luck with it. Thank you very much.